Okay, so we're talking about recurring decimals. So there's types of decimals we have. There's three types. You can have recurring decimals. Recurring decimals repeat a pattern. There's an infinite number of decimal places. The decimal places never end, but there's a pattern. Either a number is repeated over and over again, or two numbers, or it could be a pattern of 10 numbers that just repeats over and over again. And these are rational numbers. The recurring decimals are counted as rational numbers because you can write it as a fraction. That's what we're going to get on to next. So 0.777 repeater, 0.1, 2424, 124, 124, 5.4243, or whatever it is. It can be any sort of pattern. If it's repeating, it's just called a recurring decimal. Alright, another type is terminating. That's where you have a finite or a limited number of decimal places. If the decimal comes to an end, it's a terminating decimal. Yes, it's 0.85, 0.1, 0.54345, whatever. All sorts. It's just called a terminating decimal. And then the third type is non-recurring, non-terminating. And this one is an irrational number. Right, so there's infinite number of decimal places. They go on forever, and there's no pattern, no set pattern. At points, they may look like there's a pattern. Really don't even investigate them, but there's never a repeating pattern across the whole line. It's just kind of random degenerates. Pick a order, but there's just keeps going. So that's a irrational number, so non-recurring and non-terminating. And I'm sure you're familiar and work this out, but to express a fraction as a decimal, you just divide the numerator by the denominator. Okay? So are you all aware, if you ever wondering, you know how to do it on your calculator? You can turn fraction into decimal. Yeah, with the fraction button, and just shift or something. Yeah, so just press the fraction button, it goes between decimals and fractions. Okay? If ever you want to do it manually, you can do long division if you like, and divide the numerator by the denominator. Okay? To express a decimal as a fraction, you look at where it holds its place value. Is it tenths that it finishes, hundreds, thousands, 10,000, etc. Okay, you just put it as a fraction over that. So for example, if you have 0.4 as a fraction, the 4 holds the tenths value, 4 tenths. But 4 over 10, which you simplify, is 2 over 5. Very short. Well, 0.74 is 74 over 100. And then you simplify that, it becomes 37 over 50. Okay. But again, the calculator does it for you. Put the decimal in, press equals. But you should be aware, it should be very straightforward for the decimal fraction. You should just be able to write it over the appropriate power of n and just simplify what you need. Okay. But the good thing about a calculator is it simplifies it for you. You don't have to worry about doing the work. Okay? So, you should all know how to do fractions into decimals, decimals into fractions. Again, you've done it before. But what we're about to talk about is I think it's quite a quite I think it's quite a nice little piece of algebra that you have to use to find out how to put recurring decimals. And I also like this thing because you cannot use a calculator to do this. You can't use a calculator to find out a recurring decimal fraction. You have to do it manually. Okay, because you can guess and check, but some of it is just a much easier way. If you know how to do this way, you can do it very easily. That's it. to recur. Yeah, yeah. Say you have 1,000 decimal places of random numbers, and then it goes 5, 5, 5, 5, 5. That's a recurring decimal, so you can mark that as a fraction. Yes? Yeah, well, obviously, I'm not going to give you a question like that. So computers nowadays, obviously, mathematics has come a long way because computers can do billions of calculations a second, and so they can work out all these things that in the past used to be done by hand. Okay, so that's part of the reason why there's such great advances, because computer science is so far advanced. They're able to process things so quickly. Yeah, no, pi was 1,000 years. The Egyptians knew about pi. I mean, you can do long division. So all it is you can measure the circumference of a circle accurately enough, you can measure its diameter really accurately, you can get a very accurate estimate of pi by doing it by measuring. So, because a googolplex, anyway, let's not even go there right now. Okay. Okay. So basically that's it. So I expect you to be able to know this. So when comparing the values of fractions and decimals, obviously you need to get it into decimals, the easiest way. If you convert them into fractions, then you have to compare, you might have to change the denominator and that sort of thing. So just make them both into decimals, and then you can easily compare the values. That should just be this stage, so common sense something else. Change it to decimal. Okay. So they should also be able to compare fractions without too much trouble, even if you don't know the capital. Change the denominators to a common denominator, equivalent fraction, compare. Okay? So now we're going to focus on converting recurring decimals to fractions. Can I move it up a bit? That word says 2. Alright, so this is just a note about recurring decimals. You don't need to write this. So recurring decimals are rational. And by definition, we've looked at rational numbers, so you can write it as a fraction. But the thing is, there is no way on a standard calculator of inputting a recurring decimal. Even if you do fill in all the decimal places it can hold, it doesn't count as a recurring decimal. That's only to 8 decimal places when we're talking about an infinite number of decimal places. Alright? So, given this problem, there needs to be another way to do it. And so that's why we need this manual method. And it's using sort of very basic algebra. Whoever came up with this, I think, is very clever. quite a nice little method we have. And so the basic idea of this is that you're using algebra to cancel out the repeating part of the decimal. So we're going to do a little trick to subtract one thing from another and cancel out the repeating part of the decimal. Okay? So I'm going to do a few examples. So if you could just listen and look at what I'm doing. There we go. You don't need to write it unless you really want to. It's just basically saying things. Rational, you can't do it with capital. Okay. First one is convert 0.1 repeater into a fraction. Just out of interest, does anyone know what 0.1 repeater is as a fraction? It is 1/9. Very good. Yeah, so 1/9 is 0.1. Now, yes. Right, so what we're going to do is this. Now listen very carefully. What we're going to do is we're going to make up a thing called n. Right, we're just going to give a name n, and we're going to call n this repeating decimal, 0.111. I'll just do it like this, just to illustrate what's happening. So you could do that 0.1 repeater with a dot above it. Okay, that's the repeating symbol, is that. So 0.111 goes on correctly. So now what I want to do is say, well, what's 10 times n? Okay, so I'm going to say, well, what's 10n? What's 10 times this number? 1.11111. Okay, we're just shifting the decimal place. The place values are shifting one spot up, multiplying by 10. So instead of 0.1, we just get 1.1111. Now, what do you notice about the repeating decimal places? They're the same. Okay, forever and ever. They'll go on forever. So what I can do is, I can say, well, what happens if I have 10 times n minus n? These are, what? What do we call them in algebra? Numerals, and they are what terms? Like terms. Okay? So what happens is 10n minus n is 1.111 ... minus 0.1111 ... These repeating, listen carefully. These repeating decimals, they cancel out. And so what we're left with is, what's 10n minus n? 10n minus n is? No. 10n minus n is 9n. Thank you. And in this case, what does 10n, what's 9n equal to? What are we left with? No. Brock, what are we left with? No, we're not left with that. Bryce, what are we left with? We're just left with 1. You see why we're left with 1? Think of it like this. 1.1111 minus, what are we left with? That cancels, that cancels, that cancels, that cancels. We're just left with 1. So 9n equals to 1. So what's n equal to? How do I get n on its own here? I have to divide both sides by 9. So n equals, stop talking. N equals what as a fraction? 1/9, thank you. So what we have is, n is equal to 0.1111, and we found that n is also equal to 1/9. So what's our conclusion? That's right. Therefore, 0.1 repeater equals 1/9. Right, so you've used a little bit of algebra to shift it up. So write down this method, please. Have a think about it. Yes, bro. Oh, it's come across that. What? What was that? It isn't doing. What? It doesn't take forever. Just, I mean, if you write it all out, but basically the steps are sort of. Yes. Oh, it's just a convention. I don't know, man. It is what it is. Look it up and let me know. Are you writing this down? It's going to be tired of somebody talking to you. Well, because I know that. I know that, but this is the way I prove it. This is the proof for it. How did you do it? Did you put in 0.111 in your calculator, press the subtraction button? It doesn't work. Because it can't handle it. The calculator is not sophisticated enough to actually generate what it means to have an infinite number of decimal places. Yeah, but how if you don't know anything about it, how are you going to do that? Just guess it. All right. Next one. You guys have had plenty of time to write it down. We've been chatting and carrying on, so I'm getting really tired of some of you complaining about it. Just listen to the next one and I'll go back to it. Just letting you know, I'm going to rearrange this room now. Take your chance. Frustrated. Right. Listening again. And the whole point of this thing, it sounds smart and say, oh, you just have to divide by 1 by 9. You didn't even know to start with that you had to have 1 and 9 in the fraction, did you? Only one person in the class knew. If I'd asked you, what is it? No one would have been able to tell me. You would have sat here for 10 minutes trying to work it out. Now that you see the method and know it's 1 9, you're like, oh, look, I know that. Yeah. So how about you actually pay attention? Stop sounding as if you know everything and listen. This is a favorite question in assessment. Listen to me carefully. This sort of question is a favorite for assessment. And you cannot deal with it. Next one, 0.54. We're going to call n. And I would appreciate if there's no whispering or muttering or talking while I'm doing this. 0.5454, we're going to call n. Now, if I multiply n by 10, it's not going to work because the decimal places have to line up exactly. The repeating decimal has to line up exactly. But if I shift it up by 2 decimal places, if I multiply it by 100, it's going to be 54.545454. In this case, we've got 2 decimal places. So now what we're going to do is we'll say, what's 100n minus n? Okay, if I do it over here, we've got 54.5454 minus 0.5454. We subtract it, all the decimal places drop out. And we're left with just with 54. So 99n is equal to 54. What is n equal to? We're looking for a fraction. Please tell me, somebody, how you solve this simple equation. What? Thank you. No, you're looking for a fraction. The whole point is we're looking to get this decimal as a fraction. So keep it in decimal form. 54 over 99. Keep it in fraction form, sorry. Sorry? So our... What does it say? 6 over 11. So 0.54 repeater is equal to 6 over 11. That's this as a fraction. You have to match up the repeating part. Yeah, that's right. Yeah. Okay. Matt, you have a question? Yeah. So I'll ask you later. Yes, Brittany. Because I want to think about how do I match these up. If I just multiply by 10, this would be 0.5454, but I would have 5.4545. So the 5.45 and the 45 don't match. I wouldn't cancel each other out. Okay? So we're trying to cancel out all the repeating parts. Well, because I'm saying to cancel out these, I have to subtract them. So what I'm doing is taking away this value from this value. And with my symbols, I'm saying this is n and this is 100. Alright, best thing is to try. I'll do another example. Yeah. Well, no, you have to do it to both. So you have to have 99 and then divide it. Okay, let's have a look at this one. Last example. We've got 0.38, call it n again. So the repeating part is the 8282. Okay, so that's the repeating part. And so I've got to think about, well, how much do I want to shift it up by? And so you can actually experiment. What's 10n? Okay, 10n equals 3.8282. And if I put n next to it, 0.38282, dot, dot, dot. Does that match up? So it's not going to work. We'll just get another repeating decimal if we subtract it. Yeah, so then the next thing would be to try it by 100. Alright? So let's try it by 100 and say, right, what's 100 in? That's 38.28282. Does that match up? Sure. That matches, okay, those are different, but then these match up, these match up, these match up. So we can actually use this, and I'll show you the way that we do this. So 100n equals 38.2828, dot, dot, dot. Alright. And so if we do 100n minus n, if I subtract these, what's going to happen is minus, so this 2 cancels out, these 8s cancel out, these 2s cancel out, 8s cancel out. Now what I'm left with is 38.2 minus 0.3. So you do the old, so you get 9, 37.9. Is what that is. So we got 37.9. So we have 99n equals 37.9. Take this over to here. So then if I divide both sides by 99, we have n equals 37.9 over 99. What's the problem with this fraction? Can't have a decimal. Travis, how are we going to fix this? The easiest way to get rid of 1. Yeah, times top and bottom by 10, and you move the 1 decimal place across, and that'll be it. So if we times top and bottom by 10, this equals 379 over 990. Put it into your calculator. Does it simplify at all? No, so that's it. So 0.382828282828 is equal to 379 over 900. Yes? Not in this case, you could use 10,000, but it wouldn't need to really. All right.